All right, this is our graphing activity where we're actually going to be looking at position versus time graphs and velocity versus time graphs and trying to match them to various situations. But before we begin, I thought we'd just make sure we review position versus time graphs and velocity versus time graphs and what we can expect to see. So I'm going to start by just sketching a quick little position versus time graph. Okay, so we're going to match the position on this axis, we're going to put the time on this axis. And now as we go through, we've got kind of some various situations that could happen. So let's say our object is not moving at all. Okay, if it's not moving at all, it might be maintaining its position the entire time. And as it's maintaining that position the entire time, we see that it creates a line that's going to have a zero slope. So we have zero slope, which means that we're not moving. So this is a case where we're not moving at all. Okay, so when we look at this, again, our slope would be something like we'd measure it in meters, we'd have our time in seconds, so our slope actually comes out to be something in meters per second, which represents how fast you're moving. So when the line is flat, you have zero slope, 0 meters per second, not moving. Okay, if we compare that to, say, a different position time graph, so let's make another one. So here's our time, here's our position. Again, we're measuring in meters, we're measuring in seconds. In this case, maybe we have a line that's going to have a slope to it. Now, that slope is actually going to show us that we have a change in our position over a change in time. So now our slope, okay, is not 0. So now the slope says that we're moving, but this is a constant motion. Okay, so you have constant motion when you're moving with a slope. Okay, now again, if the slope were steeper, we'd be moving faster. So slower, faster. Okay, so as we start with that 0, we move this direction. You can see that we're getting faster, faster, faster. And also that we're moving in the direction away from the origin. So we'd be moving in this fashion. So if we said, here's maybe our car. So we've got a little car here, okay, and the car is going to be moving down the road in this direction. That's going to show this. Now, if we saw the slope go in the other direction, so now all of a sudden, let's say our slope now goes back. So let's draw another little situation here. So here's our time, here's our position. Let's say we slope this way, but then we're going to slope back this way. So this said that we moved from this starting position. So this is always our starting position wherever our graph starts. So this is our starting position. We're moving away from our starting position out here to some maximum position. And then we start to move back towards our starting position. So at this point, the car would have had to turn around. So we had some positive velocity, okay, that went this way, but then all of a sudden we turned around and we headed back towards our origin. So this was a point where we turned around. Okay, because now this would be negative speed. Okay, this was our positive speed. So we can kind of see that we're looking at it in terms of that our rate of change is positive here and our rate of change is negative here, and we might end up back where we started. So those are some different situations with ones that are kind of constant motion. Now we can also look at our position versus time in terms of accelerated motion. So now let's look at a position versus time graph in which we're going to start down here. So we'll start here with our positioning at 0. But now what we're going to do is we're going to start slow and we're going to pick up some speed along the way. So this is going to be more of a curve. Now what this is happening, if we go back to our car situation here, our car may be started with no speed, Let's draw a new car here. So our car starts here with 0 speed, but then it's going to get faster and faster and faster and faster and faster. So the gap between our dots is going to be greater. Now that's different than when we're moving with a constant speed. In a constant speed situation, we'd almost think like these dots would always be the same distance. So it's different in how we view the two cars. So this would represent constant motion, and this would represent a changing motion. So flat lines or sloped lines versus curved lines. So this curve is going to represent that changing motion. So this changing motion is going to happen. Now what we're really doing is we're looking at kind of that slope that would be associated with each point along here, and you can see that we'd have the greatest slope here where we'd have the lowest slope here. So our slope is changing. Now anytime we see these curves, we represent this as having some acceleration. So this is acceleration. Okay, so acceleration happens whenever you see these curves. Now this would be positive acceleration, so going from slow to fast, but you could also have a curve that would be going from say fast to slow, so we could have it go like this. Okay, so now this is something that's slowing down. So in other words, we have some speed here, but now we're going less and less speed each time, so we could have curves that go that way as well. So a couple of different curves that we could experience on a position time graph. Now all of this has to be translated into velocity versus time graphs. So let's kind of go back and talk a little bit about how this relates to a velocity versus time graph. And I'm going to just see if I can change colors back here. Okay, so if we go back to our first graph, okay, our first graph was the one that was kind of this flat line, so we're not moving, okay, which means that our velocity was 0, so we have 0 velocity. It also means that our acceleration is 0, so we have 0 acceleration. So if we try to map this graph out, okay, we'll look at this. I like to draw my v velocity time graphs so that we can see both positive sides and negative sides. But we can see that we had 0 velocity the entire time for that first graph. So in other words, we would have no velocity at any point. So no velocity would just be a flat line on the 0. Now that's different when we get to the graphs that have slopes. So like in this case, we had that positive slope, okay, and this one showed a more positive slope. So we could have a positive slope. Okay, this would show that positive slope. Okay, this would show a more positive slope. So in other words, this would be our slower, this would be our faster. Okay, so as we work our way up, we're getting faster and faster and faster. So more speed, more positive velocity. If we go the other direction, this would represent having negative velocity. So if we go back to looking at this graph that we did here, we had our positive speed, then we had our negative speed, and that turnaround point happened right in the middle. So if we wanted to draw that one, we could draw that one here. I'll just draw it right there. This is our velocity versus time. This is our 0. So we had some positive speed, and we get to that turnaround point, and then we have some negative speed. Okay, so this is our positive speed, this is our negative speed, and that's right here, that turnaround point. Okay, so all of these graphs kind of coordinate with each other. Now the curved one is the one that's going to be kind of more interesting when we get to our velocity time graph. So I'm going to go ahead and do a velocity versus time graph right here. So this is representing that curve right here. So we know that we started at 0 and that we're getting faster and faster and faster. So this represents that 0 velocity, and now we have to show that we're getting faster and faster and faster. So a curved graph here on that position time graph that shows the acceleration is going to be a line type graph on the velocity versus time graph. And here, this slope represents the acceleration. So we can see that that acceleration, that curve that we know is going to show that we're changing our velocities, will show up here as changing velocities, but it'll be a constant velocity change. So we'll see that as constant acceleration. Now again, that curves the other direction. We started with some speed, and now we're going towards zero. So we would have started with some speed up here, and we would have then gone until we get towards zero. So this would again show us that we had some speed, some positive speed, and we're heading towards zero velocity. And so that could be a negative acceleration, okay, or show us that we're slowing down. So that's kind of the breakdown of these graphs and how we kind of look at position versus time graphs. When you get your 3 slips of paper, we are going to be taking our situations, so you should have a pile with situations. You'll have a pile with your position versus times, and then you'll have a pile for your velocities versus times. Now generally what I'd like to do is I always like to start with the pictures, and I look at the pictures and say, well, which ones do I know have some constant motion and which ones maybe have some accelerated motion? And remember, those curves always have accelerated motion, so I'm going to make a pile of my accelerated motions. Okay, so I've got some accelerated motions. I see I've got a couple linear ones, so those are going to be my constant motion. And then this is the easy one. This is the one that has no motion. So it's interpreting those graphs. So sort them first and then see if you can match them with their situations. And you can do the same thing with your velocity graphs too. Remember, straight lines on these are representing accelerations. So these are accelerations. This would be a constant velocity. Okay, and we can see that we have accelerations, and oh, look at this one. This has got to be that one with 0 velocity, so that'll be an easy one for us as well. So you can kind of go through and break those down, and when you find the matches, you can put them together, and eventually you're going to make a chart out of these. So you can find a situation, match a position, match a velocity, and then you'll have these 3 together, and you'll make that as one. Okay, and then eventually you'll do the same thing with all of them. Keep in mind these are not correct, okay, but you'll make a chart and take a picture of your chart. Okay, so that's your activity, and I think there's a doc that you'll actually connect with as well. So good luck and have fun.